Hello everybody, welcome into another lesson. So today we are going to talk about finding the general solution of trigonometric equations. Now in the last lesson we just solved for the value of x in the interval from 0 to 2 pi. But we know in general that the domain of trigonometric equations, especially for sine and cosine, is going to be all real numbers. So how are we going to express solutions like that? Well, let's start by solving this equation. So 2 cosine of x minus 1 equals 0. This could become 2 cosine of x equals 1, which would give you the cosine of x equals 1/2. Now we have to figure out, where does the cosine equal 1/2? Well, it looks to be pi over 3, right? You would definitely have x equals pi over 3. And then cosine is also positive in the fourth quadrant, so you would have 5 pi over 3. But that only accounts for one interval. It doesn't account for the entire possibility of solutions that are infinite. To express the general solution, how you're going to do this is you're going to have x equals pi over 3 plus consider the fact that the period of the cosine function is 2 pi. So this will be pi over 3 plus 2n pi. And then you'll do the same for the 5 pi over 3. 5 pi over 3 plus 2n pi. Because it completes its period at 2 pi, so if you add another 2 pi, you'll be in the same position, just another revolution around the circle. And this goes on for infinity. So the general solutions would be x equals pi over 3 plus 2n pi and 5 pi over 3 plus 2n pi. And I got more. Alright, 3 times the tangent of x minus the square root of 3 equals 0. So this would give you 3 times the tangent of x equals the square root of 3, which means the tangent of x equals the square root of 3 over 3. Well, where does the tangent of x equal the square root of 3 over 3? At multiples of pi over 3, right? So in the interval from 0 to 2 pi, you'll have pi over 3. And then we know it's positive again in the third quadrant. So you would have 4 pi over 3. Now, to do the general solution, you have to consider the fact that the period of the tangent function is 1 pi. So you would have x equals pi over 3 plus n pi, because the tangent function completes a period in pi. So the 4 pi over 3, actually if you add pi, you'll be at 4 pi over 3. So there's no need to even list the 4 pi over 3. So that x equals pi over 3 plus n pi will account for all solutions, negative infinity to infinity, with the pi over 3 plus n pi. So you can list your solution like that. All right. So we have the sine of x equals the sine of negative x plus 1. Interesting problem here. So on the right side you have a negative angle identity. Well, let's simplify that. So the left side you still have the sine of x, but on the right hand side that sine of negative x, sine's an odd function, so this would turn into the negative of the sine of x plus 1. If we simplify further, you could end up getting 2 sine of x equals 1, which would give you that the sine of x equals 1/2. Well, okay, so where does the sine of x equal 1/2? It's going to be at multiples of pi over 6, right? And specifically in the first and second quadrant. You would get x, of course, equals pi over 6, and then you'll have it again at 5 pi over 6. But we have to use the fact that sine has a period of 2 pi. So the general solution will be x equals pi over 6 plus 2n pi, and then again at 5 pi over 6 plus 2n pi. So those are your general solutions to this equation: pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi. All right. 4 cosine of x equals 2 times the cosine of x plus 1. So this would simplify into 2 times the cosine of x equals 1. So the cosine of x equals 1/2. Now, where is the cosine of x positive 1/2? Well, that's going to be at multiples of pi over 3. So x would equal pi over 3, and then we have it again in the fourth quadrant where the cosine's positive, so you'll have also 5 pi over 3. Now the general solution is x is going to equal pi over 3, plus consider the fact that the period of the cosine function is 2 pi, so pi over 3 plus 2n pi, and then 5 pi over 3 plus 2n pi. That's how you'll account for all solutions from negative infinity to infinity. Pi over 3 plus 2n pi and 5 pi over 3 plus 2n pi. Alright, so we have 4 sine squared of x minus 2 equals 0. So this would, of course, give you 4 sine squared of x equals 2. Sine squared of x equals 1/2, which would give you that the sine of x equals both plus and minus 1 over the square root of 2. Now, you have all 4 quadrants worth of solutions. Now, okay, so if you want to consider, then, of course, the sine being 1 over the square root of 2 is at pi over 4. So x is going to equal, of course, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, those are just in the intervals from 0 to 360, because we have to consider both plus and minus 1 over the square root of 2. But there's a much better way to write this. Normally, sine is periodic for 2 pi, and it is. It's just, if we add pi over 2 to pi over 4, we end up at 3 pi over 4. If we add another pi over 2 to that, we get another 5 pi over, we get 5 pi over 4. Add another pi over 2 to that, you get 7 pi over 4, and it just keeps going and going. So really, you could say that x just equals pi over 4 plus n pi over 2. You can honestly just say that. X equals pi over 4 plus n pi over 2, because for every multiple of 90 degrees you add, or pi over 2, you end up with another multiple of pi over 4. So that would end up giving you what you need, pi over 4 plus n pi over 2. Alright, 9 times the tangent squared of x minus 3 equals 0. So we have 9 times the tangent squared of x minus 3 equals 0. Well, this would turn into 9 times the tangent squared of x equals 3. So the tangent squared of x would equal 1/3. So that means the tangent of x would equal both plus and minus 1 over the square root of 3. Well, okay, where does the tangent tend to equal multiples? What multiples give you positive 1 over the square root of 3? That'd be pi over 6, right? X would equal pi over 6. And then it's positive again in the third quadrant, which would be 7 pi over 6. And then you get negative 1 over the square root of 3 in the second and fourth quadrants. So you could have 5 pi over 6 and 11 pi over 6. That's just from 0 to 360. But remember, the period of the tangent function is only pi. So x equals that pi over 6 plus n pi. Well, if I had 1 for my n, so if I add pi to 5 pi, if I add pi to n pi over 6, I'll be at 7 pi over 6. So I don't really need to list 7 pi over 6. It occurs with this one. However, that 5 pi over 6 in the second quadrant, we definitely want to list that, plus another n pi. And then if I added pi to 5 pi over 6, I would be at 11 pi over 6, so I don't need to list 11 pi over 6. So I can list the solutions as two general solutions. X equals pi over 6 plus n pi, and then 5 pi over 6 plus n pi. Alright. Sine of x, cosine of x minus 2 cosine of x equals 0. So sine of x, cosine of x minus 2 cosine of x equals 0. Well, we could definitely factor out a cosine of x, right? So cosine of x times the quantity of the sine of x minus 2 equals 0. Well, this, okay, something interesting here. Let's take the cosine of x. Set it equal to 0. So the cosine of x equals 0. Where does the cosine of x equal 0? Just start with the fact from 0 to 2 pi. So always start with 0 to 2 pi, and then that'll help you build a framework for your general solutions. Well, the cosine is 0 when x is both pi over 2 and 3 pi over 2. That much is true. Now, here's the thing with the sine of x minus 2 equals 0. That would be sine of x equals 2. This is a good one because when does the sine of x equal 2? So here's a hint. What's the domain of your sine inverse function? It's going to be -1 to +1. This is out of the domain. So really, for the sine of x part, there's no solution to that. But we can still consider pi over 2 and 3 pi over 2. Now, granted, the period of cosine is pi, right? But if I just add pi to pi over 2, I'm at 3 pi over 2. And then if I add pi to 3 pi over 2, I'm back around to pi over 2. It'd just be 5 pi over 2. So really, I can just list my general solution as pi over 2 plus n pi. And that would take care of my general solutions, would be pi over 2 plus n pi. Alright, square root of 2 times the cosine of x, sine of x, minus the cosine of x equals 0. Well, very clearly we can factor out a cosine of x, so you'll get the cosine of x times the quantity of the square root of 2 times the sine of x minus 1 equals 0. Alright, so let's look at cosine of x equals 0. Again, in your interval from 0 to 2 pi, that cosine of x equaling 0 would occur when x is pi over 2 and 3 pi over 2. Now what about the square root of 2 times the sine of x minus 1 equals 0? So this would turn into the square root of 2 times the sine of x equals 1, which would then end up giving you the sine of x equals 1 over the square root of 2. So x is going to equal what? When is the sine 1 over the square root of 2? Definitely at pi over 4, right? And then you also have it again at 3 pi over 4 because the sine is positive in the second quadrant also. Now let's take care of all these solutions. So let's see here. We know pi over 2 and 3 pi over 2 are going to check out, right? Because the cosine of both of those is 0. We don't even have to worry about these, but what about our pi's over 4? So let's check for extraneous solutions. You still got to check for extraneous solutions. So the cosine of 2 times what is the cosine of pi over 4? Well, that's also the square root of 2 over 2 times what's the sine of pi over 4? That's the square root of 2 over 2 minus the cosine of pi over 4, so that's minus the square root of 2 over 2. Set that equal to 0. So you would end up getting 2 times the square root of 2 all over 2 minus the square root of 2 over 2 set equal to 0. Well, guess what? That just doesn't work. That's definitely not going to give you 0, so pi over 4 actually is an extraneous solution. This is why we check. Now let's deal with 3 pi over 4. We have to figure that out. So we'll take the square root of 2 times what's the cosine of 3 pi over 4? That's negative of the square root of 2 over 2 times the sine of 3 pi over 4. That's positive of the square root of 3 over 2. Positive of the square root of 2 over 2, excuse me. then minus the cosine of 3 pi over 4. That'd be minus negative of the square root of 2 over 2. See if it equals 0. So you would end up getting negative 2 times the square root of 2 over 2 plus the square root of 2 over 2 equal to 0. Well, that would give you negative of the square root of 2 over 2 equal to 0. We know that's not true. So your solutions for the sine of x part do not hold. So you actually only have two solutions. Which really we could say we have one general solution, because if you add pi to pi over 2, you get 3 pi over 2. So x would equal pi over 2 plus n pi. That would be the general solution to this particular equation. And this right here is why we always check for extraneous solutions. All right, 2 sine squared of x minus the sine of x equals 1. So this will turn into a quadratic trig equation. So this would become 2 times the sine squared of x minus the sine of x minus 1 equals 0. So we can do sine of x with a factor of 1, and then a 2 sine of x with a factor of 1 equal to 0. So let's see, this should be plus 1, that should be minus 1. All right, so we should break this down into factors of sine of x minus 1 times the quantity of 2 sine of x plus 1 equals 0. So set the sine of x minus 1 equal to 0, you just get the sine of x equals 1. Well, the sine of x equals 1 only if you're going from the interval from 0 to 2 pi, only at pi over 2. So you get x equals pi over 2 for that. Now, what about the 2 sine of x plus 1 equals 0? So that would give you 2 sine of x equals negative 1. So that means the sine of x would equal negative 1/2. Well, since the sine's negative, we know we're dealing with angles in the third and fourth quadrant, right? Where does the sine of x equal negative 1/2? That's going to be in the pi over 6 multiples. So third quadrant equivalent is x would equal 7 pi over 6. And then you'd have it again at 11 pi over 6. But before we write general solutions, let's make sure we don't have any extraneous solutions. So let's verify all of our solutions. So 2 times, now what is the sine of pi over 2? Well, that's going to be 1. That'd be 2 times 1 squared minus the sine of pi over 2, which is 1, would equal 1. So you'd have 2 minus 1 equals 1. Well, 1 equals 1, that checks out. So we know pi over 2 is going to work, but what about our pi over 6's? We don't know about that just yet. So let's see, 2 times the sine of 7 pi over 6 raised to the second power. What is the sine of 7 pi over 6? That's going to end up then being negative 1/2 raised to the second power minus your sine of negative 1/2. Sorry, that'd be negative 1/2 rather. Set that equal to 1. Okay, now, what is 2 times, let's see, what is negative 1/2 squared? Well, that'd be 1/4 minus negative 1/2, that's plus 1/2, equal to 1. 2 times 1/4 is 1/2. 1/2 plus 1/2 definitely equals 1. So 7 pi over 6 works, and you would get the same result with 11 pi over 6. So all three solutions check out. So now we need to write these in general form. So we'll have three general solutions. So we know the sine function is periodic at 2 pi. It has a period of 2 pi, so it's going to look like x equals pi over 2, pi over 2 plus 2n pi, 7 pi over 6 plus 2n pi, and then 11 pi over 6 plus 2n pi. So these will be your three general solutions to this trig equation. X equals pi over 2 plus 2n pi, 7 pi over 6 plus 2n pi, and 11 pi over 6 plus 2n pi. I have about 5 more. I just got 5 more here. So let's see. We have the cosine squared of x minus 5 times the cosine of x plus 1 equal to 0. Well, this looks like a doozy because you're going to have to do a couple things here. You're probably going to want to use what's called a U substitution. What do I mean by that? So we will let U equal the cosine of x because we're going to have to totally use the quadratic formula. Dang it, I'm sorry guys, I keep kicking stuff. There we go. We're gonna have to totally do a we're gonna have to use the quadratic formula. So this could turn temporarily into u squared minus 5u plus 1 equals 0. Now let's apply the quadratic formula. So we get u equals, well, what's the negative of b? Negative negative 5, that'd be positive 5, plus and minus the square root of that b squared, so that'd be that negative 5 squared, minus 4 times your a of 1 times your c of 1, all over 2 times a, which is 2. So u would equal 5 plus and minus the square root of 25 minus 4 all over 2, which means that it would equal 5 plus and minus the square root of 21 over 2. So now we have to turn that u back into the cosine of x. You end up getting that the cosine of x equals 5 plus and minus the square root of 21 over 2. Yes, this is just as horrendous as it looks. So let's go based on the plus first. So the cosine of x equals 5 plus the square root of 21 over 2. So where are we going to have that? Let's just look at the intervals from 0 to 360. So let's see here. So we'll have 5 plus, let's take the square root of 21, plus 5, divide that by 2. So you would actually end up getting the cosine inverse. Interesting thing here. You'll end up getting the cosine inverse of all this, which would be 4.791. Well, what is the domain of the cosine inverse? It's negative 1 to 1, so actually there's no solution there. Our best chance is if the cosine of x will work for 5 minus the square root of 21 divided by 2. What do we get? Let's see what the heck we get. That does work. You get approximately 0.209. The cosine inverse of that would work. So you get about 1.361 radians. So you get, 1.361 radians, approximately, right? Which would put you in the second quadrant, because the second quadrant is the end of the domain of the cosine inverse function. But you're also going to have another solution in the third quadrant. So what we have to do is take pi minus that answer. So you get approximately 1.781. Let's add that to pi. You would get about 4.923. So those are just the solutions for the for your second and third quadrant in general. But if you want the general solution, it's going to be x is approximately equal to 1.361 plus 2n pi. And then again at 4.923 plus 2n pi. So yes, sometimes you can get real doozies for your answer. So x equals approximately 1.361 plus 2n pi, and then 4.923 plus 2n pi. Alright, I should have here 4 more. That one was awful because we had to use the quadratic formula. All right. One minus the sine of x equals the square root of 3 times the cosine of x. Well, we have two different trig functions and a multiple of the square root of 3. I think it's safe to say we would probably want to square both sides, right? So let's do that. Let's switch sides. So this would turn into 3 times the cosine squared of x would equal, if we square the right side, you would get 1 minus 2 times the sine of x plus sine squared of x. Now, my piece of advice is going to be, let's turn that cosine squared of x into a form of sine squared. We know if we take 1 minus sine squared, you get cosine squared. So this would turn into 3 times the quantity of 1 minus sine squared of x equals 1 minus 2 sine of x plus sine squared of x. So this would be 3 minus 3 sine squared of x equals 1 minus 2 sine of x plus sine squared of x, which could simplify into 4 sine squared of x minus 2 sine of x minus 2 equals 0. Well, we could factor out a common 2. You'll end up getting 2 sine squared of x minus sine of x minus 1 equals 0. This should factor, let's see, we'll have sine of x, 1, and then 2 sine of x, and then 1. Let's see, that'd be plus, and then a minus. Okay. Yep, that should totally work. So this should break down into factors of the sine of x minus 1 times the quantity of 2 sine of x plus 1. Well, let's figure out sine of x minus 1. That would turn into the sine of x equals 1. When does the sine of x equal 1? Definitely, and from 0 to 2 pi, it would have to be x equals pi over 2. Now, what about 2 sine of x plus 1 equals 0? So that would give you 2 times the sine of x equals negative 1, which would give you that the sine of x equals negative 1/2. Well, you have two solutions in both the third and fourth quadrant. So sine of pi over 6 gives you 1/2. If we're going to the third and fourth quadrant, that would be 7 pi over 6 and 11 pi over 6. But we want to first check for any extraneous solutions before we classify a general solution. So let's put these into the original equation. So 1 minus the sine of pi over 2 equals the square root of 3 times the cosine of pi over 2. Well, sine of pi over 2 is 1, so 1 minus 1 equals square root of 3 times the cosine of pi over 2, which is 0. We know that's true, so pi over 2 is going to work. But what about 7 pi over 6 and 11 pi over 6? Alright, so 1 minus the sine of 7 pi over 6. Set that equal to the square root of 3 times the cosine of 7 pi over 6. Alright, so what is the sine of 7 pi over 6? That's negative 1/2, right? So you'd have 1 minus negative 1/2 equal to the square root of 3 times, now what is the cosine of negative 7 pi over 6? That's negative of the square root of 3 over 2, since you're in the third quadrant. So this would be saying that 3/2 equals, that'd be negative 3/2. Well, we know that's not true, so 7 pi over 6 does not hold. But what about 11 pi over 6? Would that hold? Alright, so this time let's take 1 minus the sine of 11 pi over 6. Set that equal to the square root of 3 of the cosine of 11 pi over 6. Well, okay, so 1 minus, now the sine of 11 pi over 6, the sign's still negative in the fourth quadrant, you would end up getting 1 minus negative 1/2, which would equal the square root of 3 times the cosine of 11 pi over 6. That's in the fourth quadrant. It'll be positive. So times the square root of 3 over 2. This would turn into 1 plus 1/2 plus a half would equal 3/2, which we know 3/2 equals 3/2. So 11 pi over 6 will hold, but 7 pi over 6 won't. So we have two general solutions to this equation. And we know that for sine and cosine, for both of them, the period is 2 pi. So we're going to take x, we're going to have pi over 2 plus 2n pi, and then we'll have 11 pi over 6 plus 2n pi. Those would be the two general solutions to this particular equation. All right, I got 3 more. So we have the square root of the sine of x is equal to 2 times the sine of x minus 1. Very interesting. So we have a square root. Evidently, then, you're going to want to square both sides. So this would give you the sine of x equals, if you square this side, you would get 4 sine squared of x minus 4 sine of x plus 1. So this would turn into 4 sine squared of x minus 5 sine of x plus 1 is equal to 0. So let's see, this should turn into sine of x with a 1. It should all be minus 1s, and then 4 sine of x minus 1. Alright, so sine of x, let's see, 4 sine squared minus sine of x minus, yep, that would all check out. So you have the quantity of sine of x minus 1 is equal to 0, and then 4 sine of x minus 1 equals 0. Well, let's start with sine of x minus 1 equals 0. That would give you the sine of x equals 1, which would in fact give you that x would equal pi over 2 to start with in the interval 0 to 2 pi. But what about 4 sine of x equals 1? So 4 sine of x minus 1 equals 0 would give you 4 sine of x equals 1. So the sine of x would equal 1/4. Now we know the sine is positive in both your first and second quadrant. So let's see. You'll get a first quadrant answer with the radian of 0.253. And then we got to take pi minus that answer because we want a second quadrant answer. You get 2.889. Alright, so now we just need to test these in the general equation. So what is the sine of pi over 2? That's 1. Square root of 1 is 1. then you would just get 2 minus 1, which is 1. So we know pi over 2 is going to check out. All right, so now this is where it gets interesting. We're going to have to put these in and see what we come up with. See if these will work for our general solutions. So this could get a little bit nasty. So let's see, the sine of this was 0.25. Take the square root of that answer. So you would end up getting 0.5 would equal 2 times 0.25 minus 1. So that would give you 0.5 equals 0.5 minus 1. Well, that's not going to work because you would end up then getting 0.5 equals negative 0.5. So we know that actually doesn't work. So that 0.253 radian is not going to work. And since the 2.889 is the second quadrant counterpart, which is also positive, that's not going to work either. So you really only have one general solution. You have one and only one general solution. It's going to be that pi over 2. And since sine has a period of 2 pi, that means x would then equal pi over 2 plus 2n pi. So this is why, once again, you have to check for extraneous solutions. So you're not listing wrong solutions. All right, 2 more. Cosine of x minus 1 equals negative of the cosine of x. So this would simplify then into 2 times the cosine of x would equal 1. So the cosine of x would equal 1/2. Now, when is the cosine of x going to equal 1/2? Multiples of pi over 3, definitely in the first quadrant, right? It's positive in the first quadrant, but it's also positive again in the fourth quadrant. So you'd have 5 pi over 3. And we know, let's see here, let's check and see what we get for our solutions, if we have any extraneous solutions. So let's take the cosine of pi over 3 minus 1, set that equal to the negative cosine of pi over 3. So the cosine of pi over 3 is 1/2 minus 1. Would that equal negative 1/2? Yes, you actually would get negative 1/2 equals negative 1/2. And if we put in 5 pi over 3, you'll get the same thing. So both of these solutions actually check out. So your general solutions will be x equals pi over 3. And since it's got a period of 2 pi plus 2n pi, and then you'll also get 5 pi over 3 plus 2n pi. So those would be your 2 general solutions to this equation. And I just got one more, then we're done. 6 sine of x equals the sine of x plus 3. So 6 sine of x equals sine of x plus 3. So this would simplify, of course, into 5 sine of x equals 3, which means the sine of x would then equal 3/5. Well, we know the sine is positive in the first and second quadrant, so we need a first and second quadrant answer. When we initially take the sine inverse, it's going to put us in the first quadrant. So let's take the inverse sine of 3/5. You get about 0.644 radians. Now, subtract that from pi, and you'll end up in the second quadrant. You would get about 2.498 radians. And so you would end up getting, let's see, we know you would end up getting, of course, 3/5. Well, 6 times 3/5 is 18/5. So that would be, let's see, 15/5 plus 3/5 is, 18/5. So this would actually end up working then. Both of these would work since the sign is positive, so your general solutions are going to be x is approximately equal to 0.644 plus 2n pi, since a sine has a period of 2 pi, and then you would also have 2.498 plus 2n pi. So those would be your two general solutions to this equation. So that's it for this lesson. So we only have like 2 to 3 more lessons left of this course. The next lesson is going to be sum and difference formulas for trig functions. So you can find the sine, cosine, and tangent of the sum or difference of two angles also. We're going to explore formulas for that. So I hope everyone has a great day. Take care.